Hello. Hi, everyone. I'm Scott, and I'm very happy to be here. It's nice to see everyone, and I'm really excited to talk a little bit more about technology. I really enjoyed the last presenter, and while my presentation now is not as technical, I hope it will be entertaining. So, as we heard, my name is Scott, and I work for Microsoft. This is my web page here. I also have a podcast, and on that podcast, I talk to people from all over the world about all kinds of interesting topics. I've actually had this podcast for over 750 episodes. So that is 15 years, every Thursday, talking to a new, fresh face. I've really dedicated my life to making sure that people feel welcome in technology. And that's why I'm excited to speak at this conference, because I know that this conference is dedicated to getting code into the hands of the people. What I want to talk to you today about is the art of computers. I'm going to be using PowerPoint to make this presentation. And you'll see at the bottom, I'm using machine learning and the cloud to translate my English into Urdu. I apologize if the translation is not good, but at least we're trying. I've started with my slide right here, but I don't think it looks very professional. So I'm going to make the font better. And then I think I will add a nice photograph. I think that's what people think that my office looks like. In fact, it's not. This is what my office looks like. Now, I've been doing computers for many, many years. In fact, I've been working in computers for over 30 years. And there are many people who've been working in computers for less and many people who have been working more. But I'm mostly interested in new people. I want new people to work in computers and learn how to code. So I want to say welcome to everyone who is a new or early in career programmer or coder. I want you to feel welcome by our friends here at Code Movement and by anyone that you meet online who wants you to be a programmer. I really like this picture of a magazine. This is from March of 1984, and it's a magazine in the United States that's showing a young woman, and she's programming on an older computer from the 80s. And I wish that more computers looked like this in the year 2020, as we want to encourage everyone of all genders from all over the world to become programmers and learn about computers. I thought it was nice that this was a picture from over almost 40 years ago, encouraging young people to be excited about computers. So here's our question. Are computers and programming an art, or are they a science? I think that an argument can be made for both. I think that they are both an art and a science, and I'm going to talk about these 4 items. I want to talk about solving problems. I want to talk about layers. I want to talk about composition when you compose technology. And then I will end by talking about patterns. These are the 4 things that I've learned in the last 30 years that have helped me become, I think, a good programmer. First, problem solving. Problem solving is asking a question, a yes-no question, at scale. At scale is a hard thing to express. I'm guessing the translator will do it wrong. At scale means quickly, easily, efficiently. The difference between an older programmer and a newer or an early programmer is that the older programmer can simply ask the questions faster in their head and get to an answer really quickly. And the trick here is that I want the new programmers, the early in-career programmers, to learn how to ask these questions quickly. When I teach young people how to program, very young, maybe 12 or 13, instead of teaching them how to type code, I went to this room and it was all full of young women. I think they were 13 or 14, and they wanted to learn how to code. So I said, ladies, my toaster is broken. I need to make toast. And then I stopped. And all of the young people looked around and said, I want to learn how to code. Why is he asking me about the toaster? But I didn't say anything. I paused and I made them wait. And then one young lady raised her hand and she said, well, you should buy a new toaster and then you'll be able to make toast. And that was a good thing. That was a good answer. But I said, I want you to think like a programmer. And I'm in a room full of young people, and I think you can all be really good programmers. So one of the young people said, is the power on? Do we have electricity to the toaster? And I said, that's a programmer question. That's a yes or no question. And then another young lady said, why don't you plug something else in? Plug in a light to the same outlet that the toaster is plugged into. Was there a fuse that was blown? Or perhaps something else? Do the neighbors have power? Has there been a power outage? Maybe aliens have come. One young person said, maybe aliens came and they took away all of our power. Why am I talking about toasters? Because it's not always about programming. It's about debugging. It's about answering yes and no questions. It's about thinking about the program that you're writing as a system. This is called systems thinking. You can't have a toaster that exists all by itself. That toaster exists as part of a larger system. So as the young people started to think like this, they started to think about the system. They started to think like programmers. Is the power on? Do the neighbors have power? Does the toaster work in a place like my house that has power? This is similar to debugging a function. And I think sometimes we spend time as programmers worrying about the small letters and the misspellings and the syntaxes in our programs and not about the bigger system. As you gain maturity as a programmer, you'll learn about those things. So people who are early in their career, they tend to Google for things a lot. When you are a little bit later in your career, one question can eliminate an entire class of problems. So when the young people said, does the toaster have power? That immediately split the problem in half. Okay, now we can talk about problems that involve power. We've eliminated a whole group of questions. This is a list on the left here of many, many, many questions that one can ask when one is debugging a system. Things like certificates, log files, connection strings, errors. There's a joke we have here in America. This man is Abraham Lincoln. He was one of our presidents. And there's a joke on the internet that says, it's always DNS, domain name services. And they joke that Abraham Lincoln, who has been dead for 200 years, said that. And that's good to remember because you can't trust anything that someone says on the internet. You have to ask yourself, is this the right question? This list of questions are just questions I have as a senior engineer. And the way that I learned these questions is by failing. We need to make it more comfortable and more safe for early programmers to fail. A lot of programmers in the US, and I think a lot of programmers in Pakistan, are afraid to fail because it's very competitive. They worry if they fail, their coworker will see them fail and think badly of them. But failing makes you a better programmer. Learning how to debug things quickly makes you a better programmer. So we want to encourage people to become better problem solvers in a safe place. Next, I want to talk about layering. Layering hides complexity from yourself and others. So when you create systems that have multiple layers, you're actually lying to yourself. You're hiding pieces of the system from yourself. When you have an electrical switch on the wall that turns on your toaster, you're hiding the power generator from you. You're hiding it behind that switch. When we create a function in a computer program, we hide the complexity of that program behind the function. This is an example of sending an email, and a lot of times we don't think about what's underneath that. What is hidden behind an email? If I take this and I flip it around, if I turn this around, we can see that this does not look unlike HTML and HTTP. This is web programming. So you know this already. It's very similar to programming on the web today. So email and web pages are closer to each other than we think. So when you find a problem or when you find a new technology, perhaps you already know it. You can look to the other things in your life that are similar and say, I've seen this before. I think this is a good example. On the left, we see a hard drive. On the right, we see a record player. These items are 150 years separated, but they are the same technology. We have a circular disk with information encoded on it. So when we see a new technology, like a DVD or a Blu-ray, we are reminded that it is in fact not a new technology because we've used circles to encode information for hundreds of years. When we start to compose items together and use composition, we can model relationships between software. Here's a story. There's a television show on Netflix called Altered Carbon. And in the show, there's an actor who plays an artificial intelligence. This is a picture of that actor. I like the show, and I was tweeting about the show, and I mentioned this actor. And it turned out he lived in my city, and he replied to me. So this famous actor replies to me on Twitter, and I'm feeling very special. I'm thinking maybe this man will become my friend. So I said, hey, let's have lunch, because that's a thing you do on the internet. And this famous actor on Netflix said, yes, I'll have lunch with you. And then we got to hang out together. We went to have a meal. And I recorded a podcast with this man, and I was very excited. We recorded a podcast, and it was a very good show. Unfortunately, when I returned home and I took the disk from the podcast and I put it into my computer, I saw this. Nothing. No files. I was concerned that I had spent a whole hour of this man's time and I recorded a show and now I lost it. Was the disk corrupt? Did I make a mistake? Will this man never speak to me again? It was horrible, horrible feeling. But I looked closer at the disk because I remember that there are layers. This is a composition. And I noticed that there were 300 megabytes used. Even though the disk said it was empty, Windows said there was 300 megabytes utilized. So the files must be there. I'm not an expert in this kind of work, but I know that I can peel back the layers a little bit at a time. Maybe Windows said the file is not there, but I believe that it is there. So I began to learn, and I began to read, and I dug into the disk. I dug into the data. And what I ended up finding were the 2 WAV files from my interview with that actor. And it took me almost 14 hours of debugging to find this because I'm not an expert. What's interesting about this story and what I think is powerful is that I learned a huge amount about computers while I dug for this. I reminded myself that there's nothing in the computer that's hidden from you. There's just one layer underneath and another layer and another layer, and you can peel away those layers. So I learned how the disk stored data, and I was able to take the bytes off of the disk and reassemble them into audio. And I'm still able to be friends with this actor today, which makes me very happy. Another thing that's important when thinking about software as you become a more senior engineer is patterns. So what does patterns mean? Sometimes people think it means design patterns or remembering certain ways to write code. I think patterns means I have seen that before. You remember something and then you look it up. I've been doing software since the 80s, and I can remember pieces of things that I have done from 30 years ago, and that helps me today. It doesn't mean I have a good memory. I don't remember what I had for lunch, but I do remember the feeling of solving a problem, and I remember when I have seen a problem before. This was an interesting debugging problem that I had. I spent 13 hours debugging an issue with a Raspberry Pi. I know that the Urdu translator will get this wrong. A Raspberry Pi is a computer and not a pie with raspberry. This little computer here was going to run my program, and I copied my program onto this computer, and it wouldn't work. It always worked on my computer, and it never worked on the tiny computer. And I spent a day. And I made a comparison. On the left, we see the program that works. On the right, we see the program that doesn't work. You'll notice that the program that doesn't work has had characters removed. It's had bytes removed. And the byte is 0D. What is 0D? Why 0D? What a strange thing. Well, it turns out that I was using FTP to move my program, and FTP treats files as plain text. So I was taking a binary file and copying it as plain text from a Windows computer to a Linux computer. So it was removing the carriage return. And the carriage return is the 0D character. So here's a question I have for people who are programmers. Maybe you've been a programmer for 2 years, or maybe you've been a programmer for 20. What's a carriage, and what is it returning? What is a carriage return? A carriage return is a character that moves the typewriter. It takes the carriage of the typewriter and returns it to its home position. Remember when you're typing and you go, bing, carriage return, line feed. That's a 100-year-old typewriter. I live in the future. Why am I thinking about carriages today? But I recognized this character. I recognized the pattern. I remembered 0D, and I thought, that's weird. That's very strange. And the wonderful thing about this is it will never happen again. Let's think about that for a moment. I could tell this story and tell you that I spent 13 hours of my day trying to debug this. Aren't I stupid? Aren't I foolish? Look at this foolish man spending all this time. But in my mind, this time was a gift. I learned so much in 13 hours. And now that pattern is in my head. And when it happens again, it won't take me 13 hours to catch it. It'll take me a minute. Here's the best part. Now that I've told you, when it happens to you, it won't cost you 13 hours either. You'll know, I think Scott talked about this before. Maybe I'll need to check my settings for my program. That's why it's so important to spend time at conferences like this. Why Code Movement is important, because we're sharing the knowledge with our friends and the friends we've never met before, so that they can become successful as well. So as we get towards the end of my talk and perhaps into some questions, let's ask ourselves, what can we make? What kinds of amazing technologies can we plug together? This is something that's unusual. Perhaps you don't have this in Pakistan. I have diabetes. I'm a type 1 diabetic. And I take my insulin not with needles, but with a pump, an insulin pump. And it's attached to me. It's plugged into my body. What I've done is used open source software, and I can collect my blood sugar in a database in the cloud. I can then take the information, bring it into my phone, and create an API for my body. I know what my blood sugar is. Then I can take that blood sugar and I can put it in my prompt at the command line, so I can always see my blood sugar. So here we see my command line prompt with my code, and then I can see the number that is my blood sugar, and then I can control the insulin pump and automatically give myself insulin. And I've been diabetic now for over 30 years. And the great thing about technology like this, as I know we all have friends and family who may have a disease like this, I'm not going to die of diabetes. My goal is to die of old age. And if I do, I'll know that I have succeeded. Am I an expert in medical things? I am not. I'm a member of an open source community, and I know how to layer, how to compose, and how to plug together software to solve interesting problems. This is just one exciting example of what someone who knows how to code can create. Which brings us back to our original question. Are computers an art, or are they a science? And here's the answer. Yes. Don't let anyone tell you that they are a professional. I'm learning new things every day. I graduated from college many years ago. Everything I learned was old. But I learned how to learn. There are no professionals. There are only really good learners. So if someone tells you that they have 20 years experience, If someone tells you they have 20 years experience and they use that to make you feel bad about yourself, ask yourself, do you have 20 years experience, or is it the same year 20 times? The same company, the same programming, the same thinking. Be a learner who is learning new things every year. This man is the man who created the World Wide Web. This is Tim Berners-Lee. He made the internet. Look at his job title. He said web developer. He could have said he was the web developer. He didn't even put senior web developer. This is a very modest person, and we should try to be like him. There's a thing we have in the US that you can find also in Europe called the Swiss Army knife. Do you have these? Like a little knife and a little scissors and a little... It's not good at anything. It's really very bad scissors and a very bad knife. I'm a Swiss Army knife programmer. I know a little bit of C and a little bit of C++ and a little bit of Python. It's okay to be a funny little knife that is not good at everything, but at least it's a good knife. I try to remember the basics. No matter what program you use, no matter what language you speak, think about the basics. Layering, patterns, composition. I'm so glad that you're here. I'm so glad to be here at Code Movement. This is a wonderful opportunity for us to learn from our friends. And hopefully now we'll have some questions and we'll continue with a wonderful conference. I also want to encourage you to go and learn about some of the great technologies that I get to work on at learn.microsoft.com.
Well, thank you so much, Scott. Such a great and inspiring talk. We have a question and bunch of compliments. So let's start with the question first. Can you please name 3-5 technologies we should be focusing on for the next few years to build our career?
That is a fine question. What are 3 to 5 technologies we should focus on? Understanding how the cloud works is more important than learning a specific cloud. Things like Kubernetes and containers are not as important as the concepts underneath them. Technologies come and go. I was here before Kubernetes, and I'll be here after. But why does it exist? It exists because scaling software is difficult. Making websites work for large groups of people is hard. So I would encourage people to think about fundamentals of computer science, fundamentals of cloud architecture, and fundamentals of problem solving. That's a great question. Thank you.
Thank you. So next are such compliments. So I'll start reading them. Love your work, sir. The way you explain things is a very precise manner. The next one is great talk. I would like all the young ones should watch this. Third one is indeed, Scott cleared a lot of concepts. I have to listen this video again. Another one, loves the way of demo. Definitely, I would love to watch the broadcast. And the last but not the least, thank you, sir, for sharing us your Raspberry Pi debugging. I also had a project in it, and I was facing the same problem today. I am clear at where I was wrong. Thank you so much for sharing your valuable experience and knowledge today.
That's very kind. Those are very kind compliments. Thank you.
Right. Thank you so much. And there are a lot more.
Are there any questions?
Yeah, that's just it. I got many of the compliments.
Well,
the question was the one.
If people enjoyed this talk, I would point those people to my YouTube channel, where I'm talking about computer stuff that they didn't teach you. There's all kinds of interesting questions that we learn in school, but then we go to work and we don't know them. So here I talk about what's a carriage and how to do basic text editing. Sometimes I think that they assume that we should go to school and immediately we know how to type fast and how to edit text. That can be very overwhelming. This is a video on using Git and source control that is very popular that I think people would enjoy. And to the person who asked the question about 3 to 5 technologies, I have a talk here on cloud architecture. I have a conversation about the command line and using different command lines. And I also want to point our friends who are new to programming to this video here. One of the things that I think is a problem culturally, it's not a Pakistani cultural problem, it's not a US cultural problem, it's a tech cultural problem, is that people feel overwhelmed, they feel scared, they feel frustrated by computers, but they don't have anyone to talk to. They are alone in their rooms trying to learn and trying to become successful, and they're just overwhelmed. So I made a video talking about what should you do when you just feel like this. I just don't even know what to do. We need to be able to talk about this with our coworkers and with our friends. So please do check out this YouTube. I think it's very good. And the best part is it's free.
Perfect. Another one. The question one is, can you name 3 to 4 applications you developer for Microsoft that people like us used? If any, please name it.
Applications for Microsoft that we would want someone to use. Like, I'm not quite sure I quite understand that question. Like,
I'll repeat it for you, that you develop for Microsoft.
Well,
people like
so
us used. Yeah.
I see. So things that I'm excited about are .NET, which is things like C#. I think .NET is a really powerful technology that people should look at. I think that Visual Studio Code is very important, and people should know how to use VS Code. So if I go VS Code, people should know VS Code, and they should also understand the extensions in VS Code, because the power of Visual Studio Code is the marketplace, the ecosystem. Oh, I see some fun questions in here, if I may. Someone is asking about a 10-year-old. Here's an interesting question. What should a 10-year-old learn with?
Yeah.
That's a great question. If I go to my blog and I search for kids programming, I've talked about a number of ways to teach kids how to code. Some people think you should teach them like old things, teach them old programming. That's one way. Another thing is to teach them with tools like snap circuits. I think it's exciting if a child can take a battery and some wires and make a light flash. I think that's really fun for kids to do. I have a number of blog posts where I talk about these things, and I show how I'm teaching my children how to do these things. But I would encourage people to take a look at things like codecombat.com is a fun way to learn how to code online. You can learn Python and JavaScript. And then there's Scratch from MIT. This is a wonderful program for a 10-year-old. And they can go and they can write code directly in the browser. And then finally, I would say Make Code. Make Code is just lovely program. And Make Code Arcade is really good because it doesn't require any physical objects. So here you can go and learn how to write a video game, and you get your own Game Boy. Look at this on the left here. We have our little programming game, and we can go and add in blocks. So this is great for little kids. They don't have to type. They can use blocks, and that's called Make Code Arcade. Some very good questions here.
So there's another one. What happened if your code have some bugs and it insert more insulin in your blood, or if it get wrong blood level?
That's a great question. So the question is referring back to my pancreas. And what if there's a bug? So let's think about that. Let's forget about this for a moment and let's think about software that drives a car. I have my hands on the wheel of the car, and what if the software grabs the wheel and turns to one side? I will grab the wheel and I'll turn it back. So if the software sends the wrong information here, I'll hear it and I'll look at it and I'll say, oh no, and I'll stop it. Additionally, I have limits. I've told it I can have a maximum insulin. So it might give me a bad day, but it won't kill me. So you have a limit, or what we call a governor. So it cannot simply give me unlimited insulin. And what's nice about this, though, is it allows me to control my blood sugar in a way that I can also control. And that makes me very, very happy. It's definitely better than using needles. In fact, I'll show you my blood sugar here. Oops. So this is my blood sugar in real time. And we can see the prediction here showing my blood sugar. Imagine that this is driving a car. Here are the lanes of the car. Sometimes my blood sugar goes too high. It then brings me down. If it has too low, it brings me up. It's not perfect. If you think about a car that's driving, it's a little swervy, but it's never going so far that I'll be unsafe. Good questions.
So, Rahil Kukar, have some questions?
Hey, Scott, I will read out a question for you. I hope you can hear me. So this is a problem that we have been, of course, facing in Pakistan as well. So question is what we can do to bring more women into the programming, a problem we can see, I guess, across the industry. So I'm not sure if that is the case in US as well, but this is the case in Pakistan. Can you try answering that?
That's a complicated problem, and I think it's a good question. So you're asking, how do we bring more women into programming? I think there's two aspects there. First, we don't want to chase women away when they are starting younger in beginning math. We don't want young women to feel that this is not for them. Imagine if you enter a room and you look around the room and you say, oh, these are not my people. Think about it like a religion. If you are Muslim and you enter a church, you might go, oh, should I be here? No, I'll go away. If I'm a Christian and I enter a mosque, I'll go, am I supposed to be here? But if you are welcomed with open arms, yes, come in. We'd love to have you here. I'm not worried about your religion. Welcome. Christians can sit with me at the mosque. Muslims can sit with me at the church. Women, children, everyone can be a programmer. So when they're coming in and they go, am I supposed to be here? We, the programmers who are already inside the room, have to say, welcome, come, sit. Then, when they're already here, we need to not chase them away. If a woman or a person who doesn't look like me has a question, if we'll say if Rahman or Nabil says, Scott, I have a question. I have this bug in my program. And I go, oh, so stupid. Fine, I'll tell you how to do. Oh, so dumb. What a horrible, horrible thing. But here's the deal. Someone at your job has made you feel like that, have they not? Someone at your job has said, move, I'll just type. See, that wasn't so hard. Well, maybe I shouldn't be in technology if you're going to treat me like that. We have to make technology a safe place for everyone. If a new woman or a new man or a new person that you've never met before from a culture that you're not familiar with joins your team, how do you make them welcome? If a woman joins your team and she's here to code and you ask her about why is she unmarried and who are her family and where are her people from, she came here to do her job. Think about these things when we ask our new friends and our new people who we want to be in. So you can't say, I want more women to code and then not treat them as your equal when you're coding. That's my answer. I apologize if that was too aggressive of an answer, but it's my truth.
So the next question is coming from Ata. Over to you, Atta. Please read out your question.
Hey, Scott, I hope you can hear me fine.
I can.
Okay, I am Atta H. I am over here in Islamabad with Raheel, Nabil, and everyone else. Okay, I have a question, and that is if we go a few years back, then we were more relying on a server-side computation. Like say if I take an example of ASP.NET Classic or maybe web forms or that period. Then there comes an era when we started to relying on the client-side technology because one of the reason were like the servers were more strong in computation with respect to the clients, but it is not the case now. But if I take a look at the cloud computational, don't you think we are going back to rely again on the server side computational more as compared to the client side? How do you think about that?
I think that's a really good question. This is an iPhone. It's a couple years old, but it's still good. It's quite strong. Even an inexpensive Android phone is far more powerful than the computers I coded on even 5 years ago. This thing has 8 gigs of RAM and a quad processor. We're not using this device's power enough. So my opinion is that we should not be pushing so much work to the cloud when we have a pocket supercomputer right here. The limitation is usually the bandwidth. But once the data is here, if I've sent a list of data to this device, and then I choose to sort it in a grid or maybe make a chart, why would I send the data back to the server and have the server sort it and then bring it back over here again? You see how strange that is? If we think about that, are we saying that this pocket supercomputer is unable to sort a list? It's unable to make a graph or a map? I don't think we should be pushing all this work to the server. I think we should find a balance where we know the responsibility of the client and the responsibility of the server. I think we need to recognize that phones and computers are more powerful now than they were in the past. So I don't think we'll see a switching back to web forms or classic ASP. I think we'll see new technologies like Blazor and WebAssembly, and we'll have a mixed responsibility between the client and the server. That was a wonderful question. Thank you for that.
Thank you.
So thank you so much. I guess we're done for today. And now it's time for a little short break, for a tea break. And thank you so much once again, Scott. It was nice and very inspiring speech.
Thank you so much for having me. It was a lot of fun.
Thank you very much.
Thanks, Scott. Bye.
We'll be back live after 15 minutes. Thank you.